Today we will learn about chance and probability. Suppose you are playing a game of snakes and ladder with your friend. You have to walk only 3 places to win, and it is your turn to throw the dice. If you throw the dice, will you get the number 3? Think. You cannot say with certainty whether you will get the number 3 or not. But there is a possibility or chance of getting 3. Can you tell me what is the chance of getting 3 in this situation? Think. Let me tell you. Throwing the dice is an experiment which can have outcome 1, 2, 3, 4, 5 or 6. We say that in the experiment of throwing a dice, the total number of outcomes is 6, since we are required to get 3. Therefore, the number of desired results, that is, the number of favorable outcomes is 1. In this way, we can say that the number of favorable outcomes is 1 out of all 6 outcomes. This is why we say that the probability of getting a favorable outcome is 1 out of 6, that is 1 by 6. To know the probability better, let's understand some of the terms used in its context. An experiment in which more than one result is possible and the result cannot be accurately predicted is called a random experiment. Can you give any example of a random experiment? Think. Let me tell you, tossing a coin, getting a candy from the candy box without looking into it, etc. are all the random experiment. Can you tell me if the experiments like to taste the sweets and find if it is sweet or not, to drop the stone from a certain height and see if it hits the ground or not, are also random experiment? Think. Sweets will always be sweet. Similarly, if anything falls from some height, it definitely comes to the ground. That means, in such situation, we know in advance the result of such experiments. Therefore, we cannot call them random experiments. Now think, if we toss a coin, whether the chance of getting a head will be greater or the chance of getting a tail will be greater. Think. On tossing a coin, the chance of getting a head is equal to the chance of getting a tail. We say that the outcomes are equally likely. Now imagine if we write numbers 1, 2, 3, 4, 5 and 6 on the faces of a matchbox and toss the matchbox. Will the probability of getting each number in this case be equal? Think. You are right. Since the size of faces of the matchbox are different, the probability of getting each digit will also be different. Therefore, here the outcomes cannot be equally likely. Each outcome of an experiment or a collection of outcomes make an event. For example, when we rotate a dice, then in this random experiment, getting one of the outcomes from 1, 2, 3, 4, 5 or 6 is an event. Similarly, getting a number which is greater than 3 or getting an even number is also an event. Let's talk about the event of getting a number greater than 3. Here, favorable outcomes are 4, 5 and 6. In this way, there are 3 results of the occurrence for the event of getting number greater than 3. But any number 1, 2, 3, 4, 5 or 6 can come up in this experiment. So, here the total outcomes are 6. For the event of getting number greater than 3, the probability of an event is the ratio of the number of favorable outcomes of the event to the total number of outcomes in the experiment. Here, the probability of getting a number greater than 3 will be 3 by 6 is equal to 1 by 2. If the event is certain, for example, getting any number from 1 to 6 on the dice, then the probability is 1. And if the event is impossible, like getting the number 7 on the dice, then the probability is 0. But when an event is likely to occur, such as obtaining a number greater than 3, then the probability is greater than 0 but less than 1. In this way, the probability of any event can be 0 or more than it, but 1 or less than it. Now, let's look at some situations related to use of chance and probability in real life. During elections, people are asked about their choice. The number of answers received is used to find the probability of winning of each candidate, and exit polls are obtained based on it. Suppose your elder brother has got 85% marks in the government examination. If last time 1,800 students have been selected out of 2,000 candidates who have secured 85% marks, then we can say that the probability of selection of your brother is 1,800 divided by 2,000, that is 9 out of 10. Now, you can find out more such situations by yourself. Today we have learned about chance and probability. In the next video, we will see some interesting examples related to them.